This is a re-recording of a session presented at the summer 2017 PA County Pros Training Day. This session is going to be covering automating workflows with Python. I'm Patrick McKinney. I'm a GIS specialist with Cumberland County. I work over near the Harrisburg area. And at the time of the recording, at the time that I presented this session, I was the president of PA Magic, although I'm now just a regular member. I have my email address up here, and I also have my GitHub site. This is a more technical talk, so if you have some questions and want to follow up, feel free to email me at any time. And the sample script I'm going to show today, as well as some other sample Python scripts and web mapping scripts, are available on GitHub, so you may want to check those out as well. So the outline for today, we're going to be talking about automating workflows with Python with the case study of data replication. So we're assuming you've set up a replication. So we would be automating, synchronizing the changes between the databases. I'll then cover where you can learn Python and ArcPy. I'll do a brief recap about what Python and ArcPy are. And then we're going to get into the real heart of this session. We're actually going to dissect this sample data replication script line by line, and I'm going to review what the code's doing. And then I'm going to review how to take that script and set it up as a scheduled task so that you could maybe run replication every day at 6 p.m. And to close this session, I'll be reviewing some examples of how Cumberland County and the South Central Task Force group have been automating our workflows with Python scripts. So I imagine many of you, being county GIS professionals, are aware of what data replication is. But for those not, I'll do a brief overview. So you're managing your data sets in an enterprise geodatabase with SDE. You might be using versioning workflows. So let's say, your planning department, public safety department, and conservation district all have file geodatabases on their servers. And so you've already set up the replication. So let's say you're making edits for a new subdivision. So you're putting in some new parcel lines, you're putting in some new street center lines, and you're adding a park. So when you run those synchronize those changes, because you have those same layers in these three separate geodatabases, and you have those global IDs, you basically push the changes. So any adds, deletes, or changes from your enterprise database to the planning database. So you'd have a separate replication set up for planning, public safety, and conservation. And so you can automate that synchronized changes, which is great because it can allow you to run weekly or even daily data replication. And so there's many ways to synchronize those changes. You can actually open the distributed geodatabase toolbar and synchronize changes from there. You can right-click on the parent or child geodatabase and synchronize the changes. You can create a model and model builder to synchronize the changes. And lastly, you can create a Python script to synchronize the changes. The great advantage of the Python script is it can be set as a scheduled task in Windows Task Scheduler to be repeated. And one important thing is that I know many of you maybe don't know much about Python or maybe scared about Python, but the great thing about this session is I have this template script, and you can actually create a model, and then you can export that model as a Python script. You can copy that code from the model into this pre-canned script I'm going to give you, and make a few other changes, and you have your Python script. So there's something here for the Python programmers and those that aren't into programming. There's something here for everyone. So I wanted to take a look at, some time savings. And the time savings aren't anything, to write home about, but I think the big takeaway is the less things you're having to worry about doing manually, that allows room for you to be focusing on other things. And the more and more repeatable tasks that you can set up a scheduled task, it frees up time to work on hopefully more important and interesting things. So it took about 6 minutes per week to manually run replication for 5 departments. So that's around 5.5 hours per year. And so if it took you 5 hours to create the script, which in this case, it shouldn't take you that long because I've done the heavy lifting. But if it took you 5 hours to create the script, after around a year, you would now have time you didn't have before. And if you add on other tasks that you can schedule, that's more time. And more importantly, you have this nice base script that can be reused. And this base script can write the results to a text file or write any errors that occurred as well. So there's a lot of great benefits far beyond the small time savings you get. So are you confused? This is a word cloud I made from the Python documentation. So during my presentation, I asked how many people had no experience with Python, who had a little bit, and who felt pretty comfortable. I can't do that, but I'm sure you can identify with one of those groups. So I think as GIS professionals, it makes a lot of sense for us to try to learn some basic Python skills because there's a lot you can do with Python. Within the ArcGIS desktop, ArcGIS Pro environment, you can automate a lot of workflows. So you can use scheduled tasks to run repeatable workflows that don't have inputs, outputs that change. You can build custom geoprocessing tools. So maybe there's things that occur on a monthly or quarterly basis or more frequently, but the inputs and outputs change. Well, you can build a custom geoprocessing tool that maybe does 5 steps, but there's just one tool window you have to work with. Then there's the Python API, which allows you to use Python with ArcGIS Online and web mapping services. And if you get outside of the Esri platform, you can do a lot of Python scripting with software like QGIS. So I think it makes a lot of sense to try to learn. So there's a lot of great resources to learn Python. There's some that are free, there's some that are paid. I wanted to share 3 that I've used in my journey of learning to program. So I started with Codecademy. I haven't used this in a couple years, but when I was using it, it was free, but there was a paid plan that allowed premium content. And you'd pick your language, and there'd be kind of prompts, and you'd kind of work along, complete the exercises. There was a user forum if you got hung up on things. I personally learned better from video instruction. So Udemy is like an a la carte site. They have courses for everything. So you kind of pick a course. They typically cost from like $15 to $30. Sometimes they do $5 sales. And you kind of watch the videos. The instructor goes over the content. There's usually exercises and solution videos. But my favorite resource has been Treehouse. This is $25 per month, but the instructors and content are great. It covers web programming, Python, databases, design, business skills, great instructors, great content, similar format to Udemy. You can code along in like this online code editor as they're teaching you the skills. There's quizzes, exercises, user forum. So those are some paid resources. There's a lot of free resources as well. So there's ways for you to learn. And myself and many others have taught ourselves through these resources. So once you've learned Python, you can learn ArcPy, which, as we'll see in a moment, is essentially taking the ArcGIS ecosystem and putting it into the Python environment. So you see I have some links here, and on the previous slide I had links to those online learning sites. So there's the ArcPy reference, which is kind of everything you need to know about Python. And when you go to like the reference for a geoprocessing tool, they usually have Python snippets. All of the geoprocessing tools are functions in ArcPy, which is cool. There's the Esri web courses, there's free courses, there are paid courses, and because I imagine every single county is paying maintenance, then those paid courses are free to us because we're paying maintenance. What I would really highly recommend, if you can get your county to pay like $1,500 or $1,600 and give you 3 days for training, is the instructor-led Intro to Geoprocessing Scripts in Python. This is such a great course. I was able to take this with some other counties, and it was really a Kickstarter for me and some other people to start implementing Python scripting. Really great course. It's well worth the money and the time. I know it can be hard to get counties to pay, but maybe you can go as like a task force region to get funding for it. And back in April, when I was preparing this session, there's actually 2 courses on Udemy that work with ArcPy. And then when you're working with your Python scripts and you have questions, which are going to come up, there's some great online resources. GI Stack Exchange, Stack Overflow, GeoNet. These are user forums. I've gotten great responses on GeoNet within like a day or 2. So what is Python? It's a programming language with a simple syntax. And that has to do with how the language is structured, how you write the code. It's pretty simple, it's pretty easy, it's pretty straightforward. I do some programming for web maps using JavaScript, and Python I would say is simpler than JavaScript. Python runs on the major operating systems: Windows, Mac, Linux, Unix. It allows for error handling. So what this basically means is there's ways that you can capture errors that occur and do something with them, which typically I write them to a text file, or if you're building a custom geoprocessing tool, you can add them to the dialog window. So being able to handle errors is great. You can also group code into modules and packages, and this allows you to bring code into various projects. It also allows your code to be more maintainable. I built a custom tool for our public safety office for their SARA Tier 2 facility reporting. These are facilities with hazardous chemicals. So there's this tool, there's 4 or 5 scripts. So there's the script that's basically connects to the tool that gets the user inputs. And they put in latitude, longitude for the site, buffer distances, buffer units, and an output location for an Excel file. So the one script connects those tool parameters and imports the 3 other scripts. So I have one script that takes the point, reprojects it to state plane south coordinates, and creates a multi-ring buffer. I have another script that loops through that multi-ring buffer and calculates a proportional census population for each buffer. Then I have another script that loops through each multi-ring buffer feature and selects vulnerable facilities within that and exports those sites to Excel. So if I need to add in another vulnerable facility, I just go into my vulnerable facility analysis script and update it there. If I had all the code in one massive file, it would be more difficult to maintain it. So grouping code into modules and packages and error handling are 2 of my favorite things about Python. And so as I said, ArcPy is essentially taking the ArcGIS ecosystem and putting it in Python. So you can do analysis, conversion, data management, map automation. You can use the geoprocessing tools. So you can do things like basically like go through your geodatabases and file directories and inventory. You can get a listing of map documents and your directories, feature classes with the fields and properties. If you have maybe a stream layer and a bunch of maps, and you've created a layer file, so you want all of your streams to be the same symbol, you can actually, through scripts, go through those different map documents and update the symbology so it's the same. So in addition to scheduling tasks, building custom tools, there's a lot of nice utility things that manually would take a while to do, but with ArcPy and Python scripting, they go much faster. So here's the process walkthrough of taking some sort of geoprocessing tool that you want to automate. So the first step is you want to make sure the tool runs. So you run it natively through ArcGIS. So for data replication, we would manually run synchronized changes. So then when you know it works fine, you kind of have a divergence. So if you're someone like me who just feels comfortable in a code editor, I'm going to take that data replication and I'm going to just write it as a script. But if you're not comfortable with Python, you can create a model in Model Builder of that data replication, and then you can export that model to a script. And so once you have the script, either because you've written it manually or you've exported it from Model Builder, you set it up as a scheduled task. And that's going to be the last part of this session. So this works for the programmers and non-programmers alike. So before I review a process diagram of how this script works, I wanted to talk about some key concepts when working with scripts in Python. So you need to be thinking about importing modules. And modules are kind of like plugins. They provide additional functionality. So you have to think about what modules do you need. So we need a module to be able to handle errors, to work with time, and to work with operating system. We can use try except statements to catch errors and then do something with them. I like to store a geoprocessing tool as a variable because it returns what's called a result object, and we can get that Esri system message. And then I like to record the operations of my tools to a text file. I know of some counties where they send themselves an email, and there's actually a module in Python where you can send emails. So this slide is a diagram of how the script works. So we start by importing the modules, then we get some timestamps for the current date. Then we create an empty text file. Then we run the replication, we write the results or errors to the text file, and we close the text file. And what's important is everything here in white can be reusable. You can basically take this shell script, and I have that on GitHub in addition to this replication one, and you can change out, maybe it's rebuilding the tiles for a cache service, maybe it's running compress on your SDE database. So let's get to the real heart of this session and let's walk through this script. I have the link for the script on GitHub. I'm actually going to walk us through it on PyScripter, which is a great free program for working with Python scripts. So here we are in PyScripter, and when you're working with scripts, if you have this pound symbol, this is a comment. So the script doesn't run this. This is just notes. So this is some information about what the script does. It runs replication from SDE Enterprise Geodatabase to a file geodatabase. So it's one-way parent to child. I have a description. And so important, if you want to reuse a script, I have some notes about what you have to update. So you have to update the file path for the log file, a text file that writes the results. You need to update your SDE connection. You need to update the path to the child geodatabase, and then the name and settings for the replication you're running. So we start up here and we import modules. And honestly, as I've been working with Python more and more, some of these modules aren't necessary. By the time you review this script on GitHub, I may have made some changes to it. But anyhow, we import ArcPy to get the ArcGIS environment. And then we use system and traceback to be able to handle errors. we use time to get a timestamp for how long it takes to run the geoprocessing, and we use date time to get the current date, because when we write this log file, we're going to write it. I'm almost positive I don't use OS or string. I kind of built these scripts from samples I saw from Esri, and I need to go in and kind of clean them up. But anyhow, so we're going to get these timestamp variables because we're going to append the current date when the script runs to the log file. So we have this function date time now. This gets us the current date and time. So I'll kind of print out what this looks like. We have this Python console where we can kind of test out code. So we have to import date time. This may take a few moments because sometimes it can be slow. So I'll print current time. So you can see we have the year, month, day, and the time. So now what I'm going to do is I can take that current date time and I can change it so that it's month, day, year format. So I'm going to reformat the date time just to get the current date. So date today. And you see it's month dash day dash year. And if you're going to run a script just one time a day, that's a nice format. If you're going to run a script multiple times, then I have this other version, which is month, day, year, hours, minutes, seconds. So if you're going to run a script multiple times a day, or maybe you're testing it out, that might be a better way to go. So I can print date, today, time, and we see we have the date and the time. So we're getting our date and time stamps. So now we're going to run a bunch of code in a try except statement. So basically what happens is it's going to try to run all of the code in this try clause. And if it runs successfully, it's going to skip over these except statements, and then it's going to go down and close the text file. Because when we work with files, we want to close them. But if there's an error that happens at some point, it breaks out, it goes to the appropriate except statement, it does the code on there, and then it exits. And actually, there's a better way to work with files that I'm starting to implement. And by the time you get this script, if you look at it, it may have been updated by that time. So anyhow, so we have this variable file, and actually this, instead of being file, I should call it log file, but that's beside the point. Anyhow, so we have this path to where the log file is going to be. Here's the name of it, geoprocessing report underscore curly brackets .txt. So it's a text file. And so we're going to basically, in the place of here, we're going to put this variable date today. So if I were to copy and paste this down here and print file, you can see it has the date appended. And I'm not sure why file is highlighted. I don't like that, but anyhow. So now we're going to open that file in write mode. So we're going to be able to write to it. And we're going to store that function as the variable report. So now we're going to do this start time clock. We're going to get a timestamp. We're going to start when we start running this geoprocessing, and then we're going to get a timestamp at the end. So here's now where we put the parameters for the geoprocessing. So you'd put your SD connection in here, and you would put the path to your geodatabase, .gdb. And one thing about paths, I like to use this R raw string. If you use a raw string, you can just use the regular slashes. If not, you need to use double slashes. And another thing about paths, if you're working on network drives, I would recommend using UNC paths because sometimes running scripts as a scheduled task using letter drives creates an issue. And basically, how you can do this, I'm going to mimic this, is you can like open up Microsoft Word, or you can open up Outlook, and then you paste in the letter drive. I mean, this is just a local drive, but imagine it's a letter drive. You can hyperlink it in there, and then when you were to open it, it would actually open it up and it would show the UNC path, which would have like a server name and a partition and all this other stuff for the drive. So consider using UNC paths instead of letter drives if you're going to run the script as a scheduled task. So now we're actually running that geoprocessing command, synchronize changes. So this is the command that pushes those changes from the parent to child. And we're going to store it in a variable called result because we're going to get that ArcGIS system message. So we have to pass in the parent geodatabase, the name of replication, the child geodatabase, then other properties. So it's from geodatabase 1 to 2 in favor of 1. Some other things you can read about. So then when we're done running geoprocessing, we get another timestamp, and then we have this variable elapsed time. So we basically finish time on a start time. We're basically figuring out how long it takes. So let me kind of give you an example of how this works. Port time. So you can just time us how long it took. So then we have what's called a loop. So basically, while we have this property of result, the status, which has to do with whether the tool is completed, started. So a code of 4 is completed. So until we get that status code that is completed, we're going to run this command time.sleep. And what time.sleep does is it basically delays. So we're just going to kind of hang out here until we get that result code of 4. Then once we get the completed code, we're going to get the ArcGIS system messages, and that's kind of that long-winded message. So we're going to get that message. Then we're going to write to our text file. We're basically going to write in that ArcGIS system message. Now, in addition to having that ArcGIS system message, I like to have a more human-readable message. So I would have successfully run replication from the parent database to the child database and how long it took on today's date. Maybe you just want the simple message. Maybe you just want the ArcGIS system message. Maybe you want both. So it finishes running the replication, no errors, then it closes the text file. Now let's talk about what happens if there's an error. So maybe this script is going to run at Friday at 6 p.m. You left for the day at 12, and somebody in maybe the planning department, for whatever reason, they renamed this geodatabase. So this script's going to run. It's going to run fine. It's going to get down to here, and it's going to throw an error because this child geodatabase doesn't exist. So it's going to stop here, and then it's most likely going to go into this exception is E. And so what's going to happen is, E stands for error, is we have this line here. This is going to get us the line number. So this is going to end up being line 62. So we're going to write that it failed at line %I. This is another way of doing a placeholder. So this is saying it's going to be an integer. And then we substitute it in for this variable. So it's going to basically say it failed at line 62. And then we're going to write that error message. And it's going to essentially say that that geodatabase does not exist. Now, I also have this thing called environment error. Environment errors are things that happen outside the Python system. So we're doing a similar thing there. So I'm just trying to capture Python and ArcGIS errors and other errors just to try to cover my bases. And so that's essentially the script. And you can reuse everything in the script for any geoprocessing, you basically would need to just change out the parameters and the function for the geoprocessing tool you want, and you'd probably want to update, the log file. But this is a pretty reusable script. I am going to be making some updates to it because I need to take out some unused modules, and I need to update how I'm using log files. I've recently learned better ways to handle files, and hopefully I'll get those changes posted to the GitHub before you download the script if you want to go ahead and use this. But that's essentially, walking you through this script. So let's take a look at how you can take that script and then set it up as a Windows scheduled task. So with automating the script, you use Windows Task Scheduler. And this allows you to do things like set up the script to run every Friday at 6 a.m. And so some things I've learned working with some other counties is, as I said before, I would recommend using UNC paths in the script. I found some people, the script doesn't run as a scheduled task with letter drives, but does run as UNC paths. Also beware of user permissions. Make sure the machine you're running the script on and the user running the script have the right permissions. I'm currently testing a script that hits a map service and extracts those features to a file geodatabase. And when I run the script as my user, it successfully works on my county's services and a few other county services. But when I run it as a special user my IT department created to run these scripts, I get an error message that it's like not able to access it. So I'm gonna have to work with my IT department to get permission for that user. So fair warning, sometimes it can be a pain to get the scheduled tasks to work the right way, but I think it's worth the effort because it does make life easier. So what I'm going to do is I have slides of kind of the different parameters, but I'm going to kind of quickly show you how to get there. And so you can actually, this machine at home is Windows 10, at work I have Windows 7, but you basically type in task scheduler. And it's important to note that you'll need to have administrative rights to the machine. The user will need to have administrative rights to create scheduled tasks. So we'll go ahead and let this load. So once it's loaded, you basically go to Action, Create Task. And this gets us to the setting we saw before. So I'll go back to the slides. And so we have to go through these various tabs. So this first tab is kind of like the information. So we have a name, and this is a name that appears in the listing of scheduled tasks. You can see your user who created the task, a description. I like to make these pretty good, detailed. So for replication, I would actually put the server path to the SDE and the server path to the geodatabase. And you can change user. As I said, we in Cumberland County have a special user who runs our scheduled tasks. This was primarily done because we have to change our passwords every so often, and we didn't make that apply to this special user we have. I like to select run whether user is logged on or not, and then run with highest privileges as well. And this configuration, there's a couple options. You'll kind of have to figure out which drop-down works best for your organization. So then you're setting the task trigger, and that's basically telling it when to run. So you can actually run tasks on events like computer boots or user logs on, but I think for us, most of these scripts would be on a calendar. So on a schedule, when? So it's going to run weekly, every single week, on Friday at 6 a.m., and this is the first date. So you could run things every day, multiple times a day, I guess. Monthly, quarterly. There's a lot of flexibility. And you need to make sure you check enabled. If you don't check enabled, then the task will never run. So once we've set when we want the task to run, we tell it what we want to run. So we're going to run Python. So you need to move to wherever Python is installed on your machine. So we're going to run Python, and we're going to run the script. So the name of the script .py, and this script is located in here. Once again, if it's on a network drive, make sure to use UNC pass. So you're basically saying, I'm going to run Python running this script located in this directory. Then these last two tabs, conditions and settings, I don't know as much about these, but I'll just mention, you see an option that you can start the task only if the computer is idle for so long. You can wake the computer to run the task. You can allow the task to be run on demand, so you can run it whenever outside of the scheduled times. If it fails, you can restart it every so often, up to so many times. If it takes longer than so long to run, you can stop it. So if like a script should take 10 minutes to run, but it's still running after 4 hours, there's probably some sort of issue with your computer or server. And then you can force it to stop if it doesn't end. And so I would say, something I forgot to mention before, is that test your script through PyScript or make sure it runs. Once you know it's working as a standalone script, then you can start testing it as a scheduled task. And you may need to work with your IT department to get it to run as a scheduled task. Even to this day, I still have some scheduled tasks where the script runs as my user, but as a scheduled task, it doesn't run. And I'm still working through that as well. So to close, I wanted to talk about how we at Cumberland County and in the South Central Task Force are using scheduled tasks. So we're replicating data to FileGeo databases to like 5 departments. So this is typically to a FileGeo database on a department's server. We're actually replicating to the local C drive of a machine in our EOC. We're rebuilding our address locators. We have a composite locating geocoding service, which has 2 locators, one that's built off address points and one that's built off road center lines. And we use that geocoding service in our road mapping applications. We also use it in our day-to-day operations in ArcMap. We're rebuilding tiles for cached map services. And then with the South Central Task Force, we were doing quarterly updates where we had built a custom geoprocessing tool. And so we actually took that tool and reformatted it as a script that can be run as a scheduled task. And so on a monthly basis, we have counties either running the script standalone or as a scheduled task that basically extracts the data to a local geodatabase, zips it up, uploads it to our FTP. Then we have scheduled tasks for the scripts that basically take those county data sets and update our regional data sets in SDE. And we're currently testing a script that instead of using the FTP method, it hits a map service, whether an unsecured map service or secured map service, and updates the data from the map service. So using that method, we wouldn't even need counties to run the FTP and could potentially do weekly data updates. And something else that you could use scheduled tasks for is compressing enterprise database. I know Esri recommends as their workflow to analyze data sets, rebuild indexes, compress, analyze data sets, rebuild indexes. So you can put all that in a script. I even have seen a script that basically stops and starts all services. So that whole process of compressing the database, you can automate that as well. And as I said, if there's some sort of geoprocessing task or GS task that I do that recurs and the parameters never change, it's just kind of the same thing. So like rebuilding address locators, rebuilding tiles for a map service, then I'm going to use that as a scheduled task. But if the inputs and outputs can change from time to time and it's a multi-step process, then I'm probably going to build a custom geoprocessing tool. So that's all that I had. Hopefully you found this useful. Hopefully if you're not into Python right now, you'll at least think about tinkering with it. And as I said, if you're not really into Python, you can use Model Builder to get a Python script version of your tool. And then you can go on to GitHub, get my sample script and reformat it. As always, you can email me if you have any questions, and I truly hope that you have found this video worthwhile. Thanks.